Good evening, sir.
Good evening, Ramarao.
Good evening, sir.
Good evening, Prasad, Sahu. We'll wait for 1 more minute and we can start, okay? Okay, let us not wait. I'm sharing my screen. Once it is visible, say yes in chat box so that we can start. Uh, anybody remember in last class till where we covered? I think water transport we covered, right? Inspection, testing and maintenance, process flowchart and importance of inspection. If I'm not wrong, this also we covered. Uh, Anybody remember? Just to cross check. Seriously, I forgot actually. Oh, Prasad, it is your first class. I'm sorry. It's okay, no problem. We are almost end of this IS 107. Hopefully, tomorrow we'll finish IS 107. From next week, we start IS 108. Hardly it will takes 2-3 classes. Mostly, yesterday session we are covering on Monday. Monday also I will take another session. So then we have IS 105. Later we'll have revision sessions. You don't worry. So we can cover again the whole syllabus. Okay. Fine. If no idea, I think I thought that only we covered the water topic as per my knowledge. I think till these slides we had also discussed this flow chart also. Different types of inspection areas we have to cover. These two slides as well. Okay, I think this slide we have to start. Yeah. Okay. So we'll cover from here. So these are the some of the inspection areas. Uh, which are the areas we are supposed to be covered in our inspections. So there are here we have standard conditions and processes and storage. So where we need initial information, process description, and also operating instructions. When you're talking about process and the storage areas, we should know the basic information about the process as well as storage conditions. Like some of the chemicals we store at controlled environment, some of the chemicals we do at ambient temperatures also. Then process description, like the procedures, etc., and operating instructions specific to the plant. Then regarding the plant integrity, so when we say integrity, how safe the plant is, here we talk about safe working limits, like for the machines, equipments, and vessels. Design, construction, inspection, and test of certificates. So we have to know before going inspection the design. I mean, for the safety, it is not required. We should know about the safety controls which are available in the system, and also whether we have any test certificates or not. When I say test certificates, we can take an example of lifting tools and tackles and pressure vessels. This has to be calibrated by the a competent person, so that they will give us the certificate. Then protective devices, which are nothing but safety relief valve, PRVs, NRVs, rupture disc, etc. Then maintenance, what kind of maintenance we are performing? Do we have any maintenance schedule, preventive maintenance, etc.? Then inspection testing, what is the frequency of inspection testing process is happening? Then inspection authority, so whether any specific authority which is defined, who are the people can do such inspections. But because some of the areas everybody will not have an access or authorization to go and visit. Then evaluation of plant integrity, so how we can evaluate in the sense you are assessing the plant integrity. How we can do? We can check based on the vessels, pipelines, pumps and auxiliary equipments, modification to the plant and equipment, and management controls. We'll check the conditions of the vessels, the design of the vessels, their operating conditions of the vessels, the safety controls on the vessels. And the same way with the pipelines. When we talk about pipelines, we'll see the compatibility of the chemicals. Then we'll talk about the joints. We talk about the leakages. We talk about the maintenance. We talk about the color coding of the pipeline, and also the labeling on the pipeline. Then pumps and auxiliaries, again also same formula with the pipelines, except color coding and the naming. Then modification to the plant and equipment. So in case of any modifications, how this process is happening. So basically, here we write the MOCs, management of change. Any modification or any changes happens, there we have to get the management approval, which means the highest authority approval. Then we can do the such changes. Okay. And also management control, how the management is controlling the processes. When I say management control, it is nothing but review, management review meetings, whether the management is interested on the processes, the management interested on the vessels and the condition, whether the management interested on the safety aspects of the plant. When we say management control, it is nothing but management review meetings. As per ISO, I mean, what is the frequency of MRM meetings? Anybody? As per ISO management systems.
Sir, I think it is 1 month.
Frequency. As per ISO 9001 quality management system, or even it is a clause actually, if I'm not wrong, the clause number 9.2 or 9.2 is internal audit, 9.3 I think management review meetings. So
Quarterly it is,
basically,
sir.
okay,
Quart- quarterly, half yearly, and yearly.
okay, quarterly, off yearly, and yearly. Okay, fine. Okay, I think I got answer from Srinivas also. Srinivas, what is your answer? Okay, quarterly. Fine. So basically, as per the management systems, there is no defined frequency. They write in such a way that as per the management systems, as per the convenience, as required. So that most of the companies in industries, they do MRM once in 6 months. Majority of the companies, because that is going to be a big task for the quality people or MR. Nowadays, the MR term has been removed from the standards, but it happens as an industry best practice once in 6 months. Even I have not seen in my experience quarterly MRM management review meetings, but there are meetings happen monthly. Monthly meetings will happen, like production review meetings happens. Quarterly will have safety committee meetings. When you say management review meeting, it talks about the complete thing. Even they talk about budgets, they talk about the production, they will see the complete performance of last 6 months. Even that is also one of the requirement of ISO. When you go for recertification, then they will ask for all this documentation. Have you done any MRM or not? Okay. Then process deviations, we have to see the what is the variables. I mean the differences, process chemistry, pressure, temperature, then the level indicators, the flow rates, even what kind of impact they can give, and also startup and shutdown procedures. How to start up, for example, maybe some of the vessels, if you take in reactors, they use only for a specific product. So once the product order completes, they'll do a cleanup, then they keep it aside. They won't use those reactors. Then again they start after 6 months, depends on the arrival of the orders. Then those times, so how you can go into startup and shutdowns. Then operational errors like sensory failures or failures in the logic, failure to act properly. These are about the systems or DCS controls or automatic controls which we have installed on the equipment, how they are working. Then emergency procedures. So when we talk about emergency procedures, we'll have on-site emergency plan. Then there they will clearly define that what are the precautions or actions to be taken while in case of any emergency alarm rises. So basically, what will happen? What we do in the case of emergency? Basic things. Let's assume fire emergency.
So first of all, we gather all the working personnel to a assembly point, a uniform point.
Mhm.
Then there is a countdown of people, the people who are gone to work, all number of people are present or not.
Mhm.
If
Then
any
later what
people
will
is
happen?
absent, if any people is absent in the assembly point meeting, then we, we send the search and rescue to the working site.
Okay. Fine. Yeah. Thanks, Prasad. So basically, in case of any emergency, so how the people will know there is an emergency situation? How the people will understand?
Communication.
How they will
Sirens. Emergency siren.
Sirens,
ah
sir. Emergency
correct.
sirens.
When we say communication, that is the one type of
Mm.
communication or message we are giving to the total occupants of the organization or all the employees or the people inside the premises, saying that "Arre baba, there is an emergency, everybody have to leave their workplace and they have to assemble at safe assembly point or assembly point." Some people call it as safe assembly point, some people call it as assembly point. It is up to the organization. Okay, so first the communication is alarm. So how the alarm rises? Who will activate alarm?
No, sir. When they are receiving the information from the work area to security or EHS personnel.
Okay, EHS person or security person will
EHS personnel
raise the
security
alarm.
or raise the alarm, emergency alarm. But
Okay,
already we have manual call points in the black work area. They are
okay,
also broke the glass and siren is coming.
yeah, perfect. So basically, the alarm may come. Sometimes they will keep the manual alarm also in the emergency control centers, especially. There, it is a kind of pedaling. We have to just rotate by hand. There also you can get the alarm or hooter. So basically, what will happen in case of any fire emergency happens, if any fire sprinkler activates or any smoke generated, any smoke detector activates, and also the other case, manual call point. So you will see the manual call points at the every emergency exit at the right side or left side. You will see the manual call point. So by using these three, sprinkler, smoke detectors, manual call points, we can automatically activate the alarm. In other case, when it is not activated, you can use the manual call points or use the manual hooter. In other case, some of the companies they have a public addressing system also. It is nothing but a mic and a speaker setup we used to see in the colleges to give any message for the total college. Same way, the public address system will be there. There also we can announce. That is at the worst case. When your firefighting system is in good condition, it has to be activated whenever any sprinkler activated or smoke or detector activated, and also whenever any manual call point activated, the fire alarm should start buzzing. Okay, then what will happen once it is started, everybody will be in rush to reach the assembly point. There will have head count. So before head count, the security person will close the doors. He will avoid the people movement in and out. Then roll call will be happen. So in case of any missing of the personnel, then immediately the rescue team search for the absent people. Okay, that is how it happens in a high level. Then fire precautions. What kind of fire precautions has to be taken? What kind of firefighting systems or detection systems or fighting systems we have? Those has to be in proper control. Okay. Now we'll see to summarize the flow chart or the list of areas we need to inspect by these few points. Okay, the serious accident rise from the loss of contaminant of hazardous substance. Therefore, these possibilities and the plant items should be inspected in detail. So wherever there is a chance of loss of contaminant of hazardous substances, which leads to serious accidents, so we have to look for or inspect those areas in detail. For example, our storage tanks, the capacities of the storage tanks, and also some of the chemicals, even it is 50 liter also, it is very serious if it in case mixed with any gutters or etc. So we have to look for any contaminants or hazardous substances leakage or handling. The most vulnerable parts of the dye plant procedure or system should be identified from the ongoing through the plant layout and process flow diagram and walking around the installation. Records of all the failure history and past incidents are useful. Then the most vulnerable parts of the dye plant, which means what is the critical system in your operations, and also their operating procedures and the systems to operate that specific critical plant by identifying the process flow or plant layout and also the process flow diagram. So there we have to look around and we also should consider the past history of accidents associated with that specific plant. Then safety arrangements should be checked also in relation to the off-site impact with the local population. So when we say off-site impact, what is mean by off-site impact? Any guess? Off-site impact.
So the
Emergency
people around
spreading
the
outside the people's account. The peoples are worried about the accident from the accident. The
Okay.
effect is going to outside when where it is going on the emergency situation. The effect is outside going.
Okay. Then came on a word in the. Is there any word to tell that? There is a word
Offsite
actually.
emergency, sir.
Ah,
Offsite
perfect.
emergency.
Yes, Ramarao. That is what I'm expecting.
Okay,
So
sir.
when we say the off-site impact, when we say on-site, the emergency which is within the limits of your boundary, nothing is exposed out of your boundaries. When we say off-site impact or off-site emergency, out of your boundary, the emergency has been extended. The emergency has been spreaded over beyond your limits. Okay, I got level 3. Srinivas, I don't know level 3. Fine, maybe it is your internal categorization of your emergency situations. Fine. Okay, there it is spreading away from the plant or your boundaries. All those incidents are called as off-site emergency situations. Okay, for example, leakage of chemicals or the toxic fumes or the gases which is spreading, and also in case of your factory tanker, the chemical tanker which is going to the client or the customer place. Meanwhile, it got an accident in between during the transportation. Okay, that is also emergency. Okay, fine. Thanks, Srinivas. Offsite emergency categorized as level 3. Okay. Okay. So we have to check for what kind of safety arrangements we have for such kind of emergencies. For example, keeping antidotes or how we are communicating those people, how we can evacuate. All these things will be there. Sometimes maintaining emergency medicines or some kind of first aid facility, or any extra emergency PPEs for such a population, etc. Now, all available expertise should be applied. Example: engineering, chemical, medical, management, etc. And a meeting and discussion with experts in the plant can be useful. So we can have to had a discussion to understand the complete process with all these experts to understand the plant operations and the safety controls better. Then competency of the occupier and contractors should be verified regarding the better choice of process, catalyst, equipment, etc. And operating pressure, temperature, residence time, etc. And also management control systems. So competency of the occupier. When you say competency of the occupier, the knowledge of the occupier and the contractor should be verified regarding the better choice of processes. When we say he is knowledgeable or he is so talented, it means that he will choose the better process or better equipments. Okay, and operator pressure, temperature, residence time, and also management controls. The competent manager or occupier always he choose the better process, systems, equipments, and controls in place. Then process documents like process description, operating procedures, safety information, emergency manual, etc. should be scrutinized for completeness and quality. So this is also one important thing. If you are joining any existing organization or you have not developed that emergency manual or emergency control system procedures, it has to be verified completely or for the completeness and quality. Okay, and also process documents, process descriptions, or operating procedures for the various kinds of operations. For example, production, quality, R&D, maintenance procedures. Okay, all the things has to be verified. The process description should be inclusive of principles involved, the basic chemistry of main and also side reactions, hazards of materials, and safety precautions, plant equipment list, and also line diagram, transport, storage, and transfer arrangements, operating parameters, and their safe limits. SOPs and the procedures are authorized process changes. Procedures are authorizing processes changes. Okay, so when we talk about process descriptions, it should give some basic informations about the chemistry. For example, if a chemist, a production chemist who is operating the reactor, he should know how to operate that reactor, what are the various controls in that reactor, which are attached to the reactor. When you say utilities, hot oil, steam, water, brain, chilled brain, etc., etc. So these all are the utilities we use to uh, increase or reduce the process temperatures. Okay. Then safety precautions which are there. Then plant and equipment list, and also the diagram, transport, storage, and transfer arrangements, operating parameters, and their safety limits. SOPs and procedures are authorizing process changes. So in case of any changes required, these SOPs and other procedures will be giving authorization, or they do a revision accordingly based on following these procedures. Then operating instruction should be include a flow sequence and also a batch sheet, conditions to be maintained, actions of the process controls and monitoring instruments, allowable variation limits, actions necessary, what that limit is reached. So these are operating instructions. As I take an example of any specific equipment, definitely you will have certain limitations while operating that machine, and also the sequence of operation. So here we are taking about a chemical process. That's why we could see the batch sheet, like batch reaction, etc., where they will written the complete the process or the activity of that specific batch or that reaction. Okay. Then process controls, monitoring instruments like pressure, temperature, the flow, etc. Allowable variation limits. Allowable variation limits in the sense the temperature plus or minus. For example, he has to heat that chemical which is inside the reactor at 50 degrees centigrade. There will be a tolerance. So 1 degree plus or minus will be the tolerance, so that the chemical reaction will not change or nothing will going to happen. That is the allowable variation limit. Even pressure, flow, etc., for everything there will be a tolerance or a threshold, and the actions necessary, what that limit is increased, emergency procedures, reporting route, and also training schedule of the operator. So for example, in case of any exceeds the limit, it is not in control, or in case of it exceeds, what will happen, what will be the consequences of that increasing temperature, increasing pressure, increasing flow. All these things has to be identified. And also emergency procedure. For example, sometimes if the utility is out of control, so what will happen, there will be a chance of runaway reaction, or it can lead to exothermic reaction. In such cases, what can be done or what should be done, and also the reporting process or reporting route, and training schedules of the operators. Okay, all these things has to be put in place. Even the training is also very important. Then for the plant integrity, safe working limits of the plant, including pressure vessels, should be carefully established as design data and compatible with normal process operating conditions. Even pressure vessels also very important. We have to maintain them at the safe working limits for the sake of plant integrity, and it has to be compatible with the other operating conditions also. It means it should match with the other operating conditions. And again, the design data should include the range of pressure, temperature, loading, flow rates, operation cycles, basis for pressure relief, and the properties of the substance. When we talk about the design data, the process design. So this process, at what pressure it will operate, and what will be the flow rates, and what will the operation cycles for one product, and other pressure relief systems and properties of the substances. What kind of type of properties of substances, or corrosives or oxidizers, solvents, which kind of properties of substances can be used in this specific vessels, etc. As an example. Okay. Oh, sorry. The plan should be designed, constructed, inspected, tested, and certified according to the design and construction code, which will achieve the safe working limits. So when we say designed, constructed, inspected, or certified according to the design. So what is the technique we use for this? To checking the design requirement or design intent. We have discussed this as well in our previous class. I'll give the word also. It starts with H. What is the technique we use? To check the design intent or the design requirement. To check the deviations of process deviations. Srinivas?
Sir, DQ, OQ, IQ.
Sorry?
DQ, OQ, IQ.
DQ, OQ, OQ. Okay, what it is?
Design qualification, installation qualification, and operation qualification.
Okay. When you talk about all together?
Yes, sir. Every equipment it is.
Okay. Fine. Okay. Maybe there is another technique which is HAZOB, Hazard Operability Study. Have you heard about Ramarao? HAZOB?
Sir.
Yeah.
Yes, yes.
Basically, this HAZOB we use for to identify all the design or process deviation. It is simply you can keep it deviations. Either you name it design deviations or process deviations. Basically, here we identify what are the intended process. So నా ప్రాసెస్ ఎలా ఉండాలనుకుంటున్నానో, నా మ్యానుఫ్యాక్చరింగ్ ఫ్లో ఎలా ఉండాలనుకుంటున్నానో అలాగే ఉందా లేదా అన్న దాని గురించి మనం హజాబ్ యూజ్ చేస్తాం. హజార్డ్ ఆపరబిలిటీ స్టడీ. And PHA
Okay,
is
sir.
before the HAZOB, Srinivas. Preliminary hazard analysis. The advanced version of PHA is HAZOB. Okay. Your 50% is correct. So PHA, the advanced version, is the HAZOB actually. This HAZOB, we do 7 guide words. It is very important. You have to remember no flow, no, or as well as,
less, more,
more
as
than,
well as another.
less than. Yeah. Okay.
More
These
and
are 7 guide words. Based on the guide words, we go through each process. There we take one process flow. We'll go by step from the raw material storage till the packing, one by one. Even if you're talking about the pipelines, you take each of one of the pipeline. In case of no flow, what will happen? In case of high flow, or along with, as well as any other materials which are coming in, what will be the effect of that change or effect of that incident, or what are the various chances of happening such causes or happening such incidents or situations. All this we assess in the hazard operability study. Okay. So protected devices may include pressure, vacuum relief valves, or rupture disc, explosion vents, high or low level alarms, high or low temperature alarms, weight tables, content gauges, maximum fill devices, padding air or gas, reducing valves, and many forms of instruments, etc. So, in your process, what kind of protective devices which are in place? This is also very important. These all things are also covered in your design itself. You have to check whether they are sufficient, whether they are properly working in manner or not. And safe system of work may include manual venting procedures, loading unloading systems, and temperature control at fill while filling. Cold contents stored below their safe temperatures may cause a brittle failure. Just a second. Okay. So, safe systems of work may include manual venting. Some of times we do manual venting. Where we do manual venting, I think maintenance people will understand this. Manual venting. For which equipments we do manual venting?
Blower and
Huh?
exhaust, sir. Blowers and exhaust,
Okay. In,
exhaust.
okay. Any other equipments?
Scrubber,
Scrubbers. Okay. What about air receivers?
scrubbing system. Yes, sir. Air
Air
receivers,
receivers we do commonly, right?
nitrogen. Yes, sir.
Because air receivers, when you have a compressed air system, the air receiver tanks will have, due to the moisture content in the air, the water will settle in the bottom. So there we do manual venting on day-to-day basis. Maybe if your system is so sophisticated, it depends on, but otherwise depends on your system. You do manual venting for this air receivers. Okay. So I'm stopping here. We have only 12 seconds. After the break, we can continue. Okay.